given that the limit as n approaches infinity of this show that this is also equal to this. So we are going to see. Now, anytime you see a of n, right, that is what? A relation which is in terms of what? N. That is representing sequence of what? That is representing sequence. And if you see a of s, that is a function in terms of what? X, or f of x. This also represents what? A function. So we are going to see whether this is the same as that. That is what we want to look at it right now. So we are going to do analysis. And the analysis that we are going to use to prove this is that here we are going to state that if we let s be less than 1, if we let s to be, if we make it to be less, to be something else, let's make it greater. If we let s to be greater than 1, alright, then we also state that n is less than s, and s is also less than n plus 1. Yes, and n is also less than n plus 1 for all n belonging to what? Natural numbers. Alright, so having this, let me state it again here, greater than 1, then x n less than s less than n plus 1. Alright. Very good. So having this, then we are going to prove by squeeze property. So by or from squeeze property. From squeeze property. Then I'm going to write 1 plus 1 over s over s. So this is going to be less than. Very good. So now, let's look at the left hand side. So the left hand side, for us to say that s is greater than 1 and n is less than x, if n is less than s or n plus 1 is greater than x, this means that, watch, this means that 1 plus 1 over the n here is going to increase by what? 1. So we get n plus 1. Then we get n plus 1 there. Then here we get it to be power x. So we change this to n plus 1. Alright? Then this one also is also going to be less than, this one also is going to be less than 1 plus 1 over n plus 1. Then the s now change to n, because we are saying that s is also less than what? N. And if s is less than n, then this one is also less than this. So this is established. I hope it's clear. Very good. Looking at the right hand side, this is what is at the middle. Looking at the right hand side, alright, we can also say that, here we can also say that, okay, here 1 plus, since we are saying that n is less than s, that means that s is greater than what? N. So here we can write 1 over s, then to increase it, we write n plus 1, because it always increases by the what? The power. And this one is going to be less than 1 plus 1 over n plus 1. Very good. So now, that is what we have for now. So from or by squeeze property, we are going to pick the left hand side and the right hand side and prove if it's true. So we are just going to focus on this, and here we focus on that. So we are going to say that the limit as n approaches infinity of 1 plus 1 over n plus 1 to the power n. To the power n. So here you can see that we are not in that form, alright? We are not in that form. So let's try to be in that form. So looking at this, we can let y to be equal to 1 over n plus 1. So as n approach infinity, y approach 0. How we can see that? So when you make n the subject, you get y multiplying n plus 1 is equal to 1. So ny plus y is equal to 1. So ny is equal to 1 minus y. Divide both sides by y. You get n to be equal to 1 minus y over y. Alright. So by substitution, we are still on the left hand side. By substitution, we are going to get the limit as y approaching 0. 1 plus y. Then the n here will be 1 over y. Please what? 1 minus y all over y. So 1 over y minus 1 over y over y. Alright? Very good. So here we are going to get, so this is the same as 1. Then this is going to be equal to the limit as y approaching 0 of 1 plus y raised to the power 1 over y times, but don't forget that here is negative, so it divides the limit as y approaches 0 of, we have already established this in our previous video, and that is going to be power 1. Now you can see that here we are going to get this to be equal to e over, but here, hope you can see from the board, I'm not supposed to be the focus, so you may not see me, but I appreciate that you can see the board, what is going on the board, right? So now, here, if you do substitution of y is equal to 0, you get 1 plus 0, and finally we get e. So on the left hand side from this, by squeeze property, we prove that this is equal to what? E. Hope it's clear. In the same way, we go from the right hand side. We are going to pick the right side. I would like to pick this. We go and pick the one at the right, the limit as n approaches infinity of 1 plus 1 over n. Then n plus 1. Is that not so? Very good. So this is the same as the limit as n approaches infinity of 1 plus 1 over n. N times 1 plus 1 over n to the power 1. Very good. Looking at only this, we know that this we are going to get e. And with this, we are going to get, this is going to multiply by 1 plus 0. Because as this goes infinity, we are going to get what? 0. So we get e times what? 1. And we are going to get what? E. So on the left hand side, we get e. On the left hand side, we get e. Therefore, we can prove true for this. can put true for this, that therefore the limit as s approach infinity of 1 plus 1 over s raised to the power s is also equal to e. So now we have issued an equivalent statement for this and that. Very good. Thank you for your time and see you in the next video. No. Now, from what we have established, we are now saying that having a sequence is the same as having a function in this form. So now let's try and see if we can get questions. So don't forget that we prove by squeeze theory or squeeze property of a sequence. So we are going to look at questions regarding to this issue, where it's in terms of what? X. If you can prove true for this. Alright, let's continue. Given that this is equal to this, and you have established that, very good. This is equal to this, it's true. Because if the limit as s approaches infinity of 1 plus 1 over s to the power s is equal to e, then we can issue the same equivalent statement for this. Alright? We can issue the same equivalent statement for this as when you are having n and we issue the same for what? For the y. We can do the same thing for this. Very good. So now we continue. So even this, it can be y or it can be, so it doesn't matter. Solution. So now let's evaluate this. So we have the limit as s approaches this 0 or infinity, 0. Okay. As s approaches 0, it doesn't matter. Let's continue. As s approaches 0, e raised to power s minus 1 over s. So here we are going to let let's say y to be equal to, going to let y to be equal to the whole of the numerator, which is e raised to power s minus 1. Alright. So to make e raised to power s the subject, we get e raised to power s equal to y plus 1. That is by sending this to this side. Then from here, we know that as s approach 0, y2 will approach what? 0. As s approach 0, y2 will approach what? 0. Because we take the limit as y approach 0. When you put s into 0, you get e raised to power 0, which is 1, and here you are going to get 0. So as s approach 0, y2 will approach what? 0. Alright. Now with this, we take ln of both sides. So let's go on and take the ln of what? Both sides. Yeah. So when we take the ln, e raised to power s is equal to ln y plus 1. Very good. Then we can say that this s can be written, we can write this as this. Is equal to ln y plus 1. By making n the subject, we get over ln e. But we know that ln e is equal to what? Sorry. Ln e is equal to 1 because this. We know that ln e is equal to 1. Thank you. Therefore, we get x to be equal to ln y plus 1. Very good. Now here we are going to do substitution. That is all why. That's the reason why we are doing all this. So we have here to be what? Y. And here is what? This. So The reason for taking the ln of both sides is to make S the subject. And that is what we have been able to what? Achieve. Alright. So by substitution, we are going to get the limit as y approach 0, no more x. Then we know that the whole of this is y over the denominator is ln y plus 1. Very good. So having this, we can rewrite this as the limit as y approach 0 of 1 over y. Hope you can see that. Very good. Ln y plus 1. Open your eyes well. If you have a over b, you can get 1 over a inverse of b. Alright, that is when this comes downward. You are going to get that. Indices. Algebra. So we get that for this, and we get the limit as y approach 0, 1 over, we want to achieve something, okay? So 1 over, now here we can rewrite this as ln y plus 1 raising to the power of, because this is the same as 1 over y. This is the same as 1 over y. So it will go and raise to this. Alright? Very good. We are getting to somewhere. So now with this, we can now solve this as, we can now solve this as 1 over watch ln the limit as y approach 0 of y plus 1 raised to the power 1 over what? Y. So we get this. We get this because we write this at where we are going to take the limit. Alright, so we can write this as this. And we know that the inside here is what is established here, which is E. Forget about the variable there, which is x and x. Alright? It can also be y, y, y. So it is true that this. So with this, we are going to get 1 over ln E. The whole of the inside is E. But ln E is equal to 1. Therefore, we get 1 over 1, and the final answer is 1. So if you are looking at this equal to this and you evaluate this, you are going to get 1. Make sure you understand it. If in case something didn't go well for you, play back the video and grab the concept, but not what chewing the final results. Alright, I'll be back with a similar one. Alright, now if only you understand the first one, you should be able to solve this question easily. Alright, good. So here we have the limits as s approach infinity of a raised to power s minus 1 over x. So what we do is that we let y to be equal to, you can use any alphabet, a raised to power s minus 1. Then here we are going to get a raised to power s is equal to y plus 1. So when you take the mean of both sides, so that you can make s the subject. So you get s ln a ln y plus 1. So s is equal to ln y plus 1, all this over ln a. Now, don't forget that as as s approach infinity, y will approach 0. You can see from here. Alright? Very good. So having this, then by substitution we get the limit as y approach 0. Then y over the same as the one we just saw. Y over x, and the s is ln y plus 1 over this. Alright. So that is x. Now, in the same thing, but you have to be careful with your algebra. Having this is the same as the limit as y approach 0. You know, here is the same as y over 1 times the reciprocal of this. So, ln a over ln y plus 1. Hope you can see that. Very good. Very good. So here we are going to get something like the limit as y approach 0. Then we get y over ln y plus 1 times ln a. So here we can write this as the limit as y approach 0, 1 over 1 negative 1 ln y plus 1 ln a. So the limit as y approach 0 of 1 over ln y plus 1. Then y raised to 1 negative 1 is 1 over y. Multiplying by ln what? A. Very good. So having this, then you know what to do. We can allow the limit as y approach 0 go inside of this and see what we are going to get. Continue with it. So we get the limit as y approach 0, 1 over ln the limit as y approach 0, y plus 1 raising to the power 1 over y. Then multiply by ln a. So the whole of this gives e. So 1 over ln e times ln a. So finally you can see that this is what? 1. So we get ln a to be our final answer for this. You can also be solving it easily as what I'm doing, but it demands constant practice. Alright? It demands constant practice. I can show you the number of times I tried going about this before getting the answer. It's not easy. It's not just one practice. You can see from the note, right? Hope you can see. You can see from the note that I first tried of this, it couldn't work. I tried of this, it couldn't work, and finally I arrived at my final answer in. So how many attempts? 1, 2, 3. So please, and even after then, I have been practicing it. I can show you a couple of it that I have been practicing it. So I urge you all to keep on what? Practicing, because practice makes a man perfect. Some don't believe that, but I believe it. Alright, thank you. See you in the next video. Or let me try if I can get any similar question to this. If I don't get, then see you in the next video. Bye bye.